Hello dear students. So in this video we will be discussing work energy power PYQ from April 2024 attempt. Let us start. Yes. So the first question that we have, it is your 4th April shift 2 question. What it says, a body is moving unidirectionally under the influence of a constant power source. Its displacement in time t is proportional to. Fine. So basically they have given that the power is constant. The power is constant, right? It's a unidirectional source. Power we know is written as force into velocity. Force into velocity is constant. We want to find out displacement as a function of t. What is the relation between your displacement and time, right? So basically what is the proportionality of x with respect to time? Fine. So F into V is constant. Force we can write as your what? Mass into acceleration. Mass into acceleration into velocity is constant. Mass, as we know, will remain constant. So we can write down A into V is, mass is also constant. So I am making it as K over here. K is a constant. Acceleration. What is our acceleration? Acceleration we know is dV by dt. dV by dt into V is equals to K. I'll rearrange this. V dV is equals to K dt. Right? V dV is equals to K dt. If we integrate it on both the sides, let's say from time t equals to 0 to t, velocity 0 to V. If we integrate it, the result we'll get over here is V square by 2 is equals to K into t. Let us rearrange this. So V square is equals to 2KT. V square is equals to 2KT. Now, V square or V, velocity, can be written as dx by dt. So dx by dt whole square is equals to 2KT, right? So dx by dt, if we simplify this, it can be written dx by dt is equals to root 2 into kt power 1 by 2. I hope this is okay, right? Now over here, this can be written as dx is equals to this root 2 into k power 1 by 2. Root 2 into k power 1 by 2, this is also will be constant. So I am taking it as another constant c. So c into t power 1 by 2 into dt, right? Let us integrate it once again. If we integrate it once again, 0 to t, 0 to x. Integration, this will be x is equals to constant c, t power 1 by 2. T power 1 by 2 integration will be t power 3 by 2 by 3 by 2. So basically, if you notice carefully, as a function of t, what is the proportionality? The displacement is proportional to t power 3 by 2, right? Check the option. If we take a look at the option, option number 3 will be our correct answer. Let us move ahead. Yeah, second question. It says a body of mass 50 kg is lifted to a height of 20 meter from the ground in two different ways as shown in figure. So one is basically, the figure is in front of you. One is directly vertically up, the block is moved. In the second case, it is moved along the incline, right? They are asking us ratio of work done against gravity in both the respective cases is. Now in the first case, if you notice, if I have to write down work done against gravity, it will be mgh, work done against gravity, it will be mg into h, right? H will be what? H will be this vertical height which is given to us as 20 meter. Fine, well and good. This is the first case. Second case, if we notice, it is your incline. The block is being moved along the incline. Now over here, this is the situation. What is our mg? Sorry, what is our force? The gravity force is mg over here downward. And if we consider work done against gravity, over here, how much is the displacement? This is our displacement. But what is the displacement in the direction of force? The displacement in the direction of force is this. This displacement S, we can break it down as Sx, and this is your Sy, right? So the displacement in the direction of force or along the direction, along the direction of force, this is equals to mg into sy, which is again displacement is in the direction is equals to height only. Again beta, if you calculate, this will come out to be your mgh only. So work done, basically the ratio will be coming out to be 1:1. The ratio will come out to be 1:1. If you see, the option will be option number 1, right? Let us move ahead. Yes. So the question that we have, it says a bullet of mass 50 gram is fired with a speed of 100 meter per second on a plywood and emerges with 40 meter per second. Let us draw the situation. Some plywood sheet is there. Basically, I have drawn it like this. Now you can understand. So the mass of bullet is 50 gram and it enters with a speed of 100 meter per second and exits out with V2. I am writing the exit speed is 50 meter per second. This is, sorry, 40 meter per second. 40 meter per second. The percentage loss of kinetic energy is, percentage loss of kinetic energies. We'll use the relation directly in one result only. We'll not calculate individually and then do the percentage change directly. Let us write down percentage change. Percentage change, and it's a loss. Obviously, it's a loss. Final velocity is 40, initial velocity is 100. So obviously there is a loss. So percentage change or percentage loss, we can write as the initial kinetic energy minus final kinetic energy divided by initial kinetic energy into 100, right? I hope this point is okay. Now let us write down initial kinetic energy will be half m v1 square, final kinetic energy is half m v2 square. So this one I can write as half m v1 square minus v2 square divided by half m initially, है ना, kinetic energy initial, which is half m v1 square into 100. Let us substitute all the values. First of all, we can see half m will cancel out. Let's substitute the values. It comes out to be 100 square minus 40 square divided by 100 square into 100. 100 cancels out. Over here, I'll use a square minus b square. So this will give us 140 a plus b into a minus b, which is 60 divided by 100. So let us cancel it. Directly it gives us 84%, right? So the percentage loss is of 84%. I hope this is okay. Let's move to the next question. Yeah. Next question. 4 particles A, B, C, D have masses m/2, m, 2m and 4m. They have equal momentum. The particle that has maximum kinetic energies, masses are given. They have given us information about momentum. They are asking us which one will have maximum kinetic energy. What is relation between kinetic energy and momentum? Kinetic energy is p square by 2m, right? We know this result. So from this we can see that kinetic energy is proportional to 1 by root m. Kinetic energy is proportional to 1 by root m. Because momentum is given constant, that's why I am looking at the focusing on your mass. As you can see that less will be the mass, more will be the kinetic energy. Less is the mass, more will be the kinetic energy. Now if you check all the 4 options, the least mass is for your particle A. That means answer is mass of A is m/2, that is the least mass. Therefore the maximum kinetic energy will be for particle A, option number 1. Let us move ahead. Okay. Next question. When kinetic energy of a body becomes 36 times of its original value, so K final is 36 times K initial, the percentage increase in the momentum of the body will be. Fine. Now beta, this question is also based on the same formula, same concept or same formula that we discussed in last question. Kinetic energy, they have given us relation. We know that kinetic energy is what? P square by 2m. So we can write final kinetic energy will be equals to final momentum square by 2m. Initial kinetic energy will be initial momentum square by 2m. Equation 1, equation 2. If we divide it 1 by 2, what will be getting? K final by K initial is equals to P final square by P initial square. 2m will cancel out, right? So from here K final by K initial, if you notice carefully over here, K final by K initial is 36. It's given to us, the data is given to us in question. So this is 36 is equals to P final square by P initial square. If I further simplify it, we'll get it P final square is equals to 36 times P initial square. If we take square root, we'll be getting P final is equals to 6 times P initial. This is the relation between momentum, we have got it. Now we have to find out percentage change. Let us see. Obviously, as you can see that the momentum is increasing, it's becoming 6 times. So obviously it will be final minus initial. There is an increase of percentage. So percentage change, we can write P final minus P initial. I hope it's visible to you here. Percentage change will be P final minus P initial divided by P initial into 100. P final is 6 times P initial. So 6 Pi minus Pi by Pi into 100. When you will solve it, we'll get 500%. 500% is coming. Let's check the options. Option is there for you people. We are getting option number 1. Option number 1 is our correct answer. Let's move ahead. Yes. So the next question we have, it says 3 bodies A, B and C have equal kinetic energies, that is Ka is equals to Kb is equals to Kc. Fine. And their masses are 400 gram, 1.2 kg and 1.6 kg. So Ma is to Mb is to Mc. If we look at it, the ratios will be, because they have given 400 gram, 1.2 gram and 1.6 gram, we can write it 1 is to 3 is to 4, right? This is what the ratio of the mass is. Fine. The ratio of their linear momentum is, now this is same, again questions are being repeated for the same concept or same formula. What do we know? Relation is kinetic energy is P square by 2m, right? In terms of momentum, if I have to write it, P is equals to root over 2mk. Because kinetic energies are given to us constant, dependent on mass, we can say that momentum is directly proportional to root m. If kinetic energies are constant, then your momentum is directly proportional to root m. So from this we can see P1 is to P2 is to, or PA, we have taken terms A, B, C. So PA is to PB is to PC. How much it will be? The ratio is root m times, है ना? Basically the proportionality is root m. So we can see it is 1 is to root 3 is to 2. Root 4 will be 2. So we are getting the answer 1 is to root 3 is to 2. Check your option. Which option it is? Option number 1. Option number 1 is your correct answer. Let us move to the next question. Yes. So let us take a look. The question that we have, it says a block is simply released from the top of an inclined plane as shown in figure. Figure is there in front of you. I have also drawn for myself. The maximum compression in the spring when the block hits the spring is, okay, let's see. So let us understand what is going to happen once this block is released. So when you release this block on this smooth incline, gravity will do work on it and it will come down. It comes down and it will gain velocity over here. It gains velocity, it starts moving, it moves on this horizontal surface. It moves on this horizontal surface and it's a rough surface. It's a rough surface, that means friction will be doing a negative work. According to the figure that is given to us, according to the figure and the data that is given to us in question, If you notice, they have given mu 0.5 only in this 2 meter. They have given mu 0.5 into 2 meter if we consider information from the diagram that is given. So over here in this 2 meter part, friction will do negative work. Once it reaches over here, it will strike the spring, and because of its velocity, it will compress the spring. Let's suppose that it compresses the spring by a distance of x. The maximum compression will arrive when velocity of the block will become 0. The maximum compression will arrive, or maximum compression of the spring will be when the velocity of the block becomes 0. Obviously, it will be momentarily, but yes, it becomes 0. So this whole process is there. In this process, in this motion of the block, three forces are doing work on it. Gravity is doing work, friction is doing work, and in this part, when this compression of spring is taking place, spring is also doing work. Let us see. We'll use the concept of work energy theorem. Using work energy theorem, work done by all forces is equals to delta K, that is K final minus K initial. Let's write what all work. Work done by gravity plus work done by friction plus work done by spring is equals to K final minus K initial. Now if you notice carefully, initially at the topmost point when you release it, velocity 0, initial kinetic energy 0. Finally, when the maximum compression will happen, block has to come to rest for a moment, but yes, it has to come to rest. So final kinetic energy, velocity will 0, kinetic energy will be 0. Well and good. So we are left with these. Let us put the value. Work done by gravity. Gravity is doing work when the block is sliding down the incline. How much will be work done by gravity? Mg into the vertical displacement. Force of gravity mg into the displacement in the direction of force, which is vertical displacement. This is 10. So this displacement, vertical displacement, will be basically 10 sine 30, right? So 10 sine 30. Work done by friction in this part of the journey, work done by friction will be mu mg into displacement is 2. Fine. Work done by spring. Now spring work done we know is, one thing over here I missed it. This work done by friction will be negative. Work done by spring is half kx square. Because spring is getting compressed, the work done by spring will be negative. If anyone has confusion regarding spring force work, force of spring will be towards left, whereas block is displacing towards right. That means force and displacement are in opposite direction, that is negative work. And work done by spring will be negative. This is all equals to 0. Let's substitute the values. Mg, that is 50, 500 into 1 by 2 minus 0.5 into 50 into 2 minus 1 by 2 into 100 into x square is equals to 0. What do we get it? It's visible here. So over here 250 minus 25 minus 50 x square is equals to 0. 200 is equals to 50 x square. 4 times x value comes out to be plus minus 2. Basically 2 is our answer. The maximum compression of the spring comes out to be 2, right? If you check the option will be option number 2. Now there is a confusion in this question. Actually there is a lack of clarity in the question, that this mu equals to 0.5, very clearly it is not that this is only for 2 meter or for this full horizontal surface. According to the diagram, I have taken this 0.5 to only for 2 meter distance and solved, we got 2, right? If let's suppose any student takes 0.5 for the whole horizontal surface, that means full surface is rough, then what will happen? In this work done by friction, the relation will be minus mu mg, and in this part of the journey friction will also be doing work. That means displacement will be 2 plus x, or I can write x plus 2, right? When you bring this term, that means this x also into picture, x plus 2 as the total displacement, or x plus 2 as the displacement for friction, work done by friction, you will get a quadratic basically. And when you will solve the quadratic, again your x value will come near to 2 only. Exactly 2 will not come, but yes, near to 2 your answer will be coming, right? Near to 2 you are something 1.78 or 1.8 around this. So that will give you idea that answer is 2. Yes, over here there is a lack of clarity that 0.5 should we take it for the full horizontal surface or only for this. If we take only for 2 meter, our answer is coming precisely 2. If you take it for the full surface, you will not get exactly 2. A quadratic will come, and when you will solve it, it will come near to something around 1.75 or 1.8. This is your answer will be coming over there, right? I hope this discussion is clear. Let us move to the next question. Yeah. Our next question we have, a particle of mass m moves on a straight line with its velocity increasing with distance according to the equation v equals to alpha root x. V is equals to alpha root x. Over here x is, I think, yes, obviously the distance. The total work done by all the forces applied on the particle during its displacement from x equals to 0 to x equals to d will be. Fine. Now let us see what can we do over here. X equals to 0 to x equals to d, work done by all forces. At x equals to 0, if we check the velocity, velocity will be how much? 0. At x equals to d, if we see the velocity, velocity will come out to be alpha root d, right? Let us find out work done. We'll again use work energy theorem. Work done by all forces is equals to delta k, which is half m v final square minus v initial square. V initial is 0 only. This is your v initial. This is your v final. V initial is 0. So 1 by 2 m v final square, if we do it, it will be alpha square into d. So our answer comes m alpha square d by 2. Right? I hope this is okay. Let's move to the next question. Yes. A force 3x square plus 2x minus 5 displaces a body from x equals to 2 to x equals to 4. X equals to 2 meter to x equals to 4 meter. Find the work done by this force. Okay. As we can see very clearly, this is a variable force. It's a variable force. So work done will be what? Integral of f dx, from where limits will be coming from 2 to 4. Well and good. Let us substitute the value. Force is 3x square plus 2x minus 5 into dx, limit 2 to 4. If we integrate it, it will come out 3x cube by 3 plus 2x square by 2 minus 5x 2 to 4. So let's substitute the values, limits over here. It will be 4 cube 64 plus 16 minus 20 minus times 8 plus 4 minus 10, right? So we get over here 60 minus 2, which is equals to 58 joule, right? Answer is coming out to be 58 joule. It's a simple question, basically work done by variable force, right? Let us move ahead. Yeah, so the question we have is a monkey carrying a sorry, not a monkey carrying, a man is carrying, not a monkey is carrying. A man is carrying a monkey on his shoulder, does cycling smoothly on a circular track of radius 9 meter. Fine, radius is 9 meter, and completes 120 revolutions in 3 minutes. That means your angular displacement is given and time is given to us. So we can write omega is equals to theta by t, right? Total how many revolutions are there? Your 120 revolutions are there. So 120 divided by 3 minutes are given to us. So we will get it over here 40. So we get over here 40 revolutions per minute. We have got omega as 40 revolutions per minute. Let us change this because we need omega in radian per second. So let us change it 40 into 2 pi by 60, right? Changing revolutions per minute to radian per second. How much we get it? 2 times, 3 times. We get 4 pi by 3 radian per second. Well and good. Next they are asking the magnitude of centripetal acceleration is, okay. Centripetal acceleration. What is our acceleration centripetal? V square by r, or I can write r omega square. In terms of omega it will be r omega square. Radius is 9. Omega we have already converted to SI system. So it will be omega square will be 16 pi square by 9. Cancels out. Answer is 16 pi square, right? Now you can check the option. It will be option number 2. Option number 2 is our correct answer. Let us move ahead. Yes. Question says a body of m kg slides from rest along the curve of a vertical circle from point A to point B in frictionless path. This is our A point. 45 degrees given, 45, okay, 45 degrees given. This is A point, this is your B point, okay. The velocity of the body at B is, some datas are given to us that the radius of this circular path is 14 meter, take G as 10 and root 2 as 1.4. Well and good. Now see over here how to do this. Basically a particle is there of mass m, which is moving along the curved surface, and this curved surface is smooth, it's frictionless. That implies mechanical energy will be conserved. If it's a frictionless surface, there is no friction, there is no non-conservative force, mechanical energy will be conserved during its motion. So we can say K initial plus U initial equals to K final plus U final. Initial is basically A point, and final is basically we are talking about your at the bottom we want to find out velocity, so B point. Finally is B point. Let us see, initially it is released, so released means 0, velocity 0, kinetic energy 0. Potential energy at this point, if we notice, if we consider this, the level, the bottom level as a reference, from this how much is the height of this one? What is the vertical height? This is your R, right? This is R, and this height will be R sine 45. R, and this will be your R sine 45. This is R cos 45. This is your R sine 45. So vertical height, potential energy, if we have to write, mg into h from this level, which is equals to R plus R sine 45. This is equals to final kinetic energy half mv square vb square plus, this is our reference we have considered, so at reference potential energy 0. Well and good. M cancels out, we get Vb square is equals to 2G, R is 14, so 14 plus 14 into sine 45, 1 by root 2. Well and good. Let's simplify this. 20 into 14 plus root 2 value they have given us, take specifically 1.4, so this becomes your 14, 10 times 20 into 24 Vb square, right beta? This is what we are getting when you will take the root of this, root of 20 into 24, your answer will come out to be 21 point something meter per second. Na? I hope you can do this part, last calculation. So if we check the answer, 21.9, and 21.9 will be your answer for this one. How to approach with this? Mechanical energy conservation. Let's move to the next question. Yes, so let us see. With this we have reached to the end of our video. This is our last question. So what it says is a circular table is rotating with an angular velocity of omega. Fine. About its axis, there is a smooth groove along a radial direction on the table. A steel ball is gently placed at a distance of 1 meter from the groove. So if I draw the figure something like this, over here there is a groove and a ball is placed at 1 meter. Okay. All the surfaces are smooth. if the radius of the table is 3 meter, the radial velocity of the ball with respect to the table, so this radius is 3 meter, the radial velocity of the ball with respect to table at the time ball leaves the table is x root 2 omega meter per second. So the velocity is given to us x root 2 omega meter per second. This is the radial velocity, right? So where the value of x is, fine. Let us understand what is going to happen when this disc will rotate. When this disc will rotate, if we see from the reference of the disc, this ball will experience a centrifugal force in radially outward direction. Due to that, a centrifugal acceleration will be there. Acceleration centrifugal, if we have to write, what do we write it? R omega square, right? But its position is changing. From 1 meter it will be 3 meter. From this it will move from 1 to 3 meter. So we can write it as a function of x. Basically we can write it as x omega square. X over here is what? This distance, because obviously this x will change, because particle will experience, the steel ball will experience centrifugal force, it moves radially outward. So as x, that is as the distance from the center changes, this acceleration will also change, right? So well and good. So we have written acceleration centripetal as x omega square. This we can write as v dv by dx. Acceleration is v dv by dx is equals to x omega square. Let us simplify, arrange it. V dv is equals to omega square x dx. Omega square x dx. If we integrate this, initially it started, let's say 0 to v, right? And over here initially it started, it was placed at 1 meter, and finally at the radius it will be 3 meter. The distance from the center will be 3 meter. So what are we getting? V square by 2 is equals to, omega square is constant, our integration will be x square by 2, limits are from 1 to 3. So v square by 2 is equals to omega square, we have 9 by 2 minus 1 by 2, right? So v square is equals to, here 2 will cancel out basically, omega square into 8. So v value is 2 root 2 omega. The radial velocity with respect to the disc comes out to be 2 root 2 omega. This is what was given to us in the question. If you compare it, we can say that x is equals to 2. X is equals to 2, right? I hope you found the video helpful. With this question, we have completed our discussion. I hope you found the video helpful. Do consider to press the like button, and also check our other videos. We have discussed, before this we have discussed the January attempt for work energy power, and also we have kinematics, Newton's laws, and your ray optics PYQs also we have done, and also you will find other chapter PYQs also on this channel. Thank you very much. Bye bye.